Okay, so hello and welcome back. So now let's talk a little bit about properties of matrix addition. And then after that we have some properties of scalar multiplication. And we have and then after that we have the multiplication of matrices. So let's talk about some properties of matrix addition. Some properties of matrix addition. Now there is, as usual, there is the commutative law, there is the associative law, there is the existence of the additive identity and the additive inverse, as you know from other, basically from basically as you know it from basically addition of numbers. Then there is the same thing exists for matrices as well. So of course probably not everything that you might know about numbers, but some of them apply to matrices as well. So first of all, the addition of matrices satisfy the following properties. We can say that the addition of matrices satisfy the following properties. First of all, there is the commutative law. And the commutative law simply means that in terms of numbers, we can say that there is, for example, in numbers you have the commutative law of addition, for example. In the case of all real numbers, for example, you can, for example, you know that 1 plus 2 is equal to 2 plus 1. Meaning that whether you say 1 plus 2 or 2 plus 1, it's going to be equal to the same number, which is equal to 3. That's called the commutative law of addition. Now the commutative law, as it turns out, works for matrices as well, because, well, whether you add, for example, you have 1, 2, 3, and 4 as a matrix, and you have, for example, 3, 4, 7, 8, for example. You add these together, that's going to be the same thing as 3, 4, 7, 8 plus 1, 2, 3, 4. And so that means that if I call this matrix A, and if I call this matrix B, that means that A plus B is equal to B plus A. Of course, we will prove this. It's pretty easy to prove these in matrices. So the commutative law is very simply, if A is equal to, is a matrix A of ij, and B is another matrix, for example, B of ij, are matrices of the same order, say for example m by n, then A plus B is equal to B plus A. Now the proof for that is as follows. You can say that A plus B is equal to as we defined A and B, is basically A of ij plus B of ij, right? Which is the same thing as A of ij plus B of ij. Now this is equal to basically B of ij plus A of ij, right? Because addition of numbers is commutative. The addition of numbers is commutative, right? And so that is the same thing as basically B of, you can basically write this as B of ij as a matrix plus A of ij as a matrix, and that is equal to basically B plus A. And therefore A and B as a matrix, having all of these conditions, A plus B is equal to B plus A, right? So the commutative law applies to basically matrix addition. Now the associative law, or you can say that the addition of matrices satisfies also the associative law. Number 2, you have the associative law. And the associative law is basically, very simply, is in terms of numbers, you can say that, for example, 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3, because this is equal to 3 plus 3, and this is equal to 1 plus 5, and this is equal to 6 is equal to 6. This is called the associative law of addition, which in terms of matrices, you can say that for any 3 matrices, A, B, and C, for any 3 matrices A, B, and C, A being equal to A of ij, and B being equal to B of ij, and C being equal to, this is uppercase C, is equal to C of ij, of the same order, say m by n, for example, say m by n, then you have A plus B plus C is the same thing as A plus B plus C. Now to prove this, you can say that you can start from any side of this equation and write basically A plus B plus C is the same thing as basically A of ij plus B of ij plus C of ij plus C of ij, and that is the same thing as basically these 2 matrices added together, which is basically A of ij plus B of ij, right? So that becomes a matrix, plus C of ij, and then of course you can of course, you can add the three matrices together, meaning that you can write basically, you can write these two matrices as one matrix, meaning that you can write A of ij plus B of ij plus C of ij, right? And since that is the case, then basically then you can write this as the same matrix. You can write it as A of ij plus B of ij plus C of ij, but then write it this way, right? You can write it this way because the addition of numbers is associative, right? Is associative. That is the reason. And so then you can separate these and write them as two separate matrices, meaning that you can write this as A of ij plus basically B of ij plus C of ij, which is equal to basically, which is the same thing as basically A of ij, this matrix plus basically B of ij plus C of ij as a matrix here, and that is the same thing as basically A plus B plus C, right? And therefore A plus B plus C is the same thing as A plus B plus C. That is basically that is basically the associative law for addition of matrices. Now, the addition of matrices also satisfies the existence of additive identity. Number 3, the existence of additive identity which is basically let A be the existence of additive identity is that would be the zero matrix, basically, meaning that if you add the zero matrix to anything, then you will get the same matrix, the zero matrix, basically the matrix itself, meaning that you could say that let A be equal to, for example, A of ij be an m by n matrix, and O be an m by n zero matrix. An m by n zero matrix. Then A plus O is equal to O plus A is equal to A. In other words, O is the additive identity for matrix addition. O is the additive identity additive identity for matrix addition. Okay, so that is that. And also the addition of matrices satisfies the existence of additive inverse. Number 4, the existence of additive inverse. The existence of additive inverse is basically the additive inverse of a matrix A is basically the negative of the matrix A, and when you add those matrices together, you will get the zero matrix, meaning that you have A plus negative A is equal to O, which is basically the zero matrix, and negative A is called the additive inverse of A. It is basically that. So now you can say that let A be equal to, for example, A of ij be any matrix, then we have another matrix as negative A, then we have another matrix as negative A, which is equal to basically negative of A of negative A of ij, as in having an order of m by n, such that A plus negative A is equal to negative A plus A is equal to O. So negative A is the additive inverse of A, or negative of A. Or negative of A. Right? So that is basically all that we have in terms of the properties of matrix addition. Now there is a couple of things related to the properties of scalar multiplication of a matrix. Properties of scalar multiplication of a matrix. So let's see what they are. Okay, so about the properties of scalar multiplication of a matrix, let's say that if, for example, if A is a matrix as basically A of ij, and B is a matrix as B of ij, be two matrices of the same order, then say, for example, say m by n, and k and l are scalars, and k and l are scalars, then number 1, k times a plus b, k times a plus b is equal to k times a plus k times b. Number 2, and also you can say that k plus l, so k times a plus b is k times a plus k times b, and k plus l times a is the same thing as k times a plus k times, plus l times a, plus l times a. Number 2 is k times a plus, now let me rewrite this as 1 and 2 so that we have, so number 2 is basically the same thing, basically k plus l times a is equal to k times a plus l times a. Now to prove this, to prove number 1, we have basically k times a plus b is equal to well, a plus b, you can write it as, so you can write this as k times a is the same thing as this matrix a of ij plus b of ij and that is the same, and you can write this as k times a of ij plus b of ij. Actually, this is a matrix, right? And then you can write this as k times, a of ij plus b of ij as a matrix, and well, you can write this as, you can of course write this as a matrix as k times a of ij, a times ij, a of ij plus k times b of ij, and that is the same thing as, then you can separate these and write them as k times a of ij as one matrix plus k times a b of ij as another matrix, and then you can take the k out, write it as k times a of ij plus k times b of ij, which is the same thing as k times a plus k times b, and therefore k times a plus b k times a plus b is equal to k times a plus, you can write it this way, is equal to k times a plus k times b, right? Now to prove number two, to prove number two that basically k plus l times a is equal to k times a plus k times a plus l times a. We have basically, you can write k times k plus l times a is equal to k plus l times this matrix, which is A of ij, which is the same thing as there is some mistake in the text here, but you have to write it as k plus l times a of ij as a matrix, which is equal to basically okay, so now you can write this as k plus l times a of ij as a matrix, and that you can write as basically k times a of ij. You can write that as basically k times, as a matrix, k times a of ij plus basically plus another matrix. So if you were to write another step, you would write it as basically k times a of ij plus l times, for example, a of ij, and then you could write it as you could write this as basically two separate matrices, meaning that you could write this as basically k times a of ij plus l times a of ij, and then you could write this as k times a of ij plus l times a of ij, which is equal to k times a plus k plus l times a, right? Which basically means that k plus l times a is equal to k times a is equal to k times l plus l times a. Now, as an example, we have so suppose that this is example number 8. Suppose that you have a matrix A as 8, 0, 4, negative 2, 3, and 6. You have this matrix, and then you have another matrix B as 2, negative 2, 4, 2, negative 5, 1, right? Of this these two matrices, I'm sorry. Then you find the matrix X. Find the matrix X such that 2a plus 3x is equal to 5b. Such that 2a plus 3x is equal to 5b. Now, this you can solve like an equation and then find your matrices, meaning that you have to first solve for x, meaning that you have 2a plus 3x is equal to 5b, and therefore you have basically you can basically transpose and do whatever it is that you do in solving equations. You can write 3x is equal to basically 5b, for example, minus 2a, and then you can write x is equal to or let me write the steps the way that they have written it over here. So you can basically, since you have 2a plus 3x is equal to 5b, then you can write it as, for example, 2a plus 3x minus 2a, and that gives you a zero matrix, of course, right? Is equal to 5b, and subtract the same thing from here, right? This is the same thing as transposing. And then you can write this as 2a minus 2a plus 3x is equal to 5b minus 2a, right? This is because I'm allowed to take this to, or instead of 3x minus 2a, I can write negative 2a plus 3x, because matrix addition is commutative. Because matrix addition is commutative, right? And then of course you know that this is the additive inverse of the matrix 2a, meaning that negative 2a is the additive inverse of negative 2a, and so the basically when you add them together, you will get the zero matrix, or which is denoted by O. So O plus 3x is equal to 5b minus 2a, right? And that is because negative 2a, that is because basically negative 2a is the additive inverse of 2a, right? And so when you add the zero matrix to any matrix, you're going to get the same matrix always. And so that is 5b minus 2a. 0 is the additive identity. I'm sorry, the O is the additive identity, right? And then you can say that then x is the same thing as divide this by 3 and divide this side by 3, 1/3, for example, times 5b minus 2a. And therefore, and then now you can calculate x. X is equal to 1/3 times, for example, 5 times b. 5 times b was basically this matrix as 2, negative 2, 4, 2, negative 5, 1, and negative 2 times a, which is basically 8, 0, and 4, negative 2, 3, and 6. Right? Now we need to do this calculation first, multiply, and then we will do the addition or subtraction, whatever you want to call it. So x is equal to 1/3 times, basically, do this matrix here. 5 times 2 is equal to 10, negative 10, 20, 10, negative 25, and 5. Negative, basically, this matrix, which is 2 times 8 is equal to 16, 0, 8, negative 4, 6, 12, and then basically we said that for subtraction, you have to add the inverse of this matrix to the first matrix, meaning that you can write this as x is equal to 1/3 times basically 10, and this is a matrix, of course, 10, negative 10, 20, 10, negative 25, and 5, and then plus the negative of the second matrix, which is negative 16, 0, negative 8, 4, negative 6, negative 12, negative 12. And then once you add them together, what you will get is basically x is equal to 1/3 times 10 plus negative 16 is equal to negative 6. Negative 10 plus 0 is equal to negative 10. 20 plus negative 8 is equal to 12. 10 plus 4 is equal to 14. Negative 25 plus negative 6 is equal to negative 31. And 5 plus negative 12 is negative 7. And then when you multiply this 1/3, when you multiply it here, you will get x is equal to basically a matrix, which is 6/3 is equal to negative 2, negative 10/3, that is a 4, that is 14/3, that is negative 31/3, that is negative 7/3, and that becomes your matrix. Right, so the matrix becomes negative 2, negative 10/3, 4, 14/3, negative 31/3, negative 7/3. That is the correct answer. Now, we have another example here, example number 9, which is basically, suppose that you have some matrix X you want to find, and this is example number 9. This is example number 9. You want to find basically x and y if x plus y is equal to 5 to 9, and x minus y is equal to is equal to 3, 6, 0, and negative 1. Now, since x plus y is equal to this and x minus y is equal to this, you can of course add these together, and you will be calculating x as a result of that, because y and negative y will give you the zero matrix, and then the result will be the matrix x basically. And then you can put matrix x's in any of these equations, and that gives you basically y. So we have basically x plus y plus, if you add this to basically x minus y, that is going to be equal to basically this matrix, which is 5, 2, 0, 9, plus 3, 6, 0, and negative 1. Now these two added together is going to give you, well, of course, if you add x plus y plus x minus y, and then you can, since matrix addition is commutative, I can write this as x plus y minus y plus x, and then x, y minus y is the zero matrix, so that gives me x plus o plus x, and that gives me then, again, matrix addition is commutative, x plus o, that is 2x plus o, and that is equal to 2x, because this is the identity matrix for addition, right? So this whole thing over here, I can write it as 2x. This whole thing over here, I can write it as 2x. And then these two matrices added together will give me 5 plus 3 is equal to 8, 2 plus 6 is equal to 8, that is 0, and that is an 8, right? That means that x is equal to, divide by 2, you will get x, and divide by 2, that is 1/2 times this matrix, which is 8, 8, 0, 8, which means that x is equal to basically 4, 4, 0, and 4, right? Now I can pick any of these equations, and for example write x plus y is equal to 5, 2, 0, 9, and now I know what my x is 4, 4, 0, 4, and I know that y has to be some matrix of the same order, meaning I will just simply write it as y is equal to 5, 2, 0, 9, right? Now, well, the right thing to do here is well, actually, I mean, technically, what I needed to do here is that I needed to eliminate, basically, I needed to eliminate x, since I'm solving for y, I need to eliminate x here. That means that I needed to write, for example, x plus y and subtract, basically add the negative of x2 to this side of the equation, and then that is equal to 5, 2, for example, 0, 9, right? And then matrix addition is commutative, then I could write this as x plus x, for example, x negative y, I'm sorry, x negative x, for example, plus y is equal to 5, 2, 0, 9, and, well, then that gives me the 0 matrix, which is O plus Y is equal to, again, this is 5, 2, 0, 9. And since O plus Y is equal to Y, then Y is equal to 5209, except that I forgot something. I forgot to subtract x from this side, because when I subtract x from this side, I have to subtract it from this side as well. So I have to subtract x from all of these equations. So now I know that my x is equal to 4404. So then y is equal to 5209 minus x, which is basically 4404, right? And then in order to subtract, I have to add the negative of this matrix back to the first matrix, meaning that I have to write y is equal to 5209 plus the negative of this matrix, which becomes -4, -4, 0, -4. And then I can simply add, meaning that I can write 5 plus -4 is equal to 1. 2 plus -4 is -2, 0, and 5. And therefore y is equal to this matrix, and x is equal to this matrix. So x is equal to 4404, and y is equal to 1, -2, 0, and 5. Okay. Now, question number 10, we have example number 10. Example 10. We have find the values of x and y from the following equation. So you have basically 2 times some matrix, which is x, 5, 7, y minus 3. That is the matrix that you have. Plus another matrix, which is 3, -4, 1, and 2. And that is equal to basically 7, 6, 15, 14. So you want to find the value of x and y. So if you multiply 2 by this matrix, you will get, which is a scalar, you can simply multiply it. We are allowed to do that, so we can say that basically 2x, 10, 14, and 2 times y minus 3 is 2y minus 6. That becomes the first matrix. Plus the second matrix, which is 3, -4, 1, and 2, is equal to 7, 6, 15, 14. Then I can add these two matrices together, meaning that this becomes 2x plus 3. 10 plus -4 is equal to +6. 14 plus 1 is equal to 15. And 2y minus 6 plus 2 is equal to 2y minus 4. That is one matrix is equal to this matrix, which is 7, 6, 15, 14. Now these two matrices are equal, so the corresponding elements are equal. That means that I can write 2x plus 3 is equal to 7, and 6 is equal to 6, 15 is equal to 15, and 2y minus 4 is equal to 14. This gives 2x is equal to 7 minus 3 is equal to 4. That means that x is equal to 4 divided by 2, which is equal to 2. And this gives 2y is equal to 18. That means that y is equal to 9. And that is the And that is the answer there. Right? We have another example here, and we have some more time to do it. So the question is basically two farmers, Ram Kishan and Gurcharan Singh, cultivates only 3 varieties of rice, namely Basmati, Permal, and Noora. So there are 2 farmers. I will call them Farmer 1 and Farmer 2. F1 for Farmer 1, F2 for Farmer 2. Okay? And they have 3 different types of rice. I call them T1, Type 1, Type 2, and Type 3. Okay? Now, the sale in rupees of these varieties of rice by both the farmers in the month of September and October are given by the following matrices A and B. So that means that the matrix A is the sale in rupees of these varieties of rice in the month of September, and then matrix B is the sales in the month of October, which means that basically you can say that September sales in rupees, and you have some matrix A which is equal to basically 10,000. Then you have 20,000, and then you have 30,000. You have 30,000. You have 50,000 there. You have 30,000 there, and you have 10,000 there. Right? So that is basically your matrix A. And so this is the type 1 of rice, whatever that is, doesn't really matter. This is one type of rice, this is type 2, and this is type 3. And so this is all related to farmer 1, F1, and this is related to F2. Now, October sales in rupees are basically, let's say that is the matrix B, and so you have 5,000, you have 10,000, and then you have 6,000 there, and then you have 20,000, you have 10,000, and then you have 10,000 there. Right, so that is that. And this is again type 1, T1, type 2, and type 3. And this is again farmer 1, and this is farmer 2. Okay. So this is the September sales, this is the October sales for both the farmers for all the 3 varieties of rice. Now what you want to do, you want to find the combined sales in September and October for each farmer in each variety. Basically you want to find the combined sales in September and October for each farmer in each variety. So how do you do that? So you can simply write, you can simply add the 2 matrices together, and that gives you, for example, type 1 plus type 2, type 1 plus type 2 plus type 2, type 3 plus type 3. and that gives you, for example, for farmer 1 and farmer for each farmer in each, basically for each farmer in each variety. So you simply write, basically, if you calculate A plus B, you can imagine that these, the corresponding elements will be added together. You will get another matrix, which is 10,000 plus 5,000 is 15,000. 20 plus 10 is equal to 30,000. 30 plus 6 is 36,000. And 50 plus 20 is 70,000. And 30 plus 10,000 is 40,000. And 10 plus 10,000 is 20,000. Right? And that is again, this is again for farmer 1, this is for farmer 2, and this is for type 1, type 2, and type 3. Now, number 2, basically part 2 of the question, you want to basically find the decrease in sales from September to October. You want to, part 2 of this question, find the decrease in sales from September to October. So in order to do that, first of all, let's see if there was a decrease. So you had 10,000, 5,000, 20,000, 10,000, and so on. It seems that there has been some decrease. So if I basically subtract B from A, that gives me the amount of decrease from September to October, which means that if I calculate A minus B, which is the same thing as A plus negative B, that gives me basically that decrease. And so what that means is that, now let me make a screenshot here of these two matrices. So A plus negative B, that would be basically, for example, that would be a matrix of the same order, but then you have, for example, 10,000. You would have basically two matrices as follows, meaning that you would have, let me actually write it down. So my first matrix would be 10,000, 10,000, 20,000, and 30,000. And then you have 50,000, and then you have 30,000, and then you have 10,000. And that is your first matrix, right? The second matrix, which is for the second matrix, you're supposed to add the negative of the second matrix, meaning that you will get negative 5,000, and that's actually 50,000. So negative 5,000, then you have negative 10,000. Then you have negative 6,000, then you have negative 20,000, then you have negative 10,000, and then you have negative 10,000. Right, so if you subtract, you will get some matrix as 10,000 minus 5,000 is equal to 5,000. 20,000 minus 10,000 is 10,000. 30,000 minus 6,000 is 24,000. 50,000 minus 20,000 is 30,000. 30,000 minus 10,000 is 20,000. And 10,000 minus 10,000 is 0. So there you have your matrix. That is the amount of decrease for farmer 1, for farmer 2 in each of the varieties type 1, type 2, and type 3. Right? So that is the second part of this question. Now, the third part of this question is if both farmers receive 2% profit on gross sales, if basically both farmers receive 2% profit on gross sales, compute the profit for each farmer. Compute the profit for each farmer and for each variety sold in October, and for each variety sold in October. So in October, the sales that we had were as follows. So the sales in October were, so basically October sales in rupees were basically the matrix B, which was basically 5,000, and then you had 10,000, and then you had 6,000, and then you had 20,000, and then you had 10,000, and then you had 10,000. Right, so that is that. Now, this is basically gross sales means, I suppose this is gross, this you can take as gross sales. And 2% profit on gross sales, you want to compute the profit for each farmer. So the profit, you just need to calculate 2% of, for example, 5,000 or 2% of 10,000. So 2% is the same thing as, just multiply this by 2%, right? So then I can write, for example, I can just simply write this as I can calculate 2% of B is equal to 2% times B, which is equal to the same thing as 0.02 times B, right? So I can simply write basically 0.02 times this matrix, which is 5,000 and 10,000 and 6,000 and 2,000 and 10,000 and 10,000. Right, so that is 2% of this, and this is a scalar. I can simply multiply. Now, if I multiply this by 2 and then divide it by 100, so that gives me 10,000. So 10,000 divided by 100 gives me 100. That gives me 100. That's 20,000 20,000 divide by 100, you will get a 200. 6,000 times 2 is equal to 12,000. Divide by 100, that gives me 120. 2,000 times 2 is equal to 4,000 times 100 gives me 40. 10,000 times 2 is equal to 20,000. Divide by 100 gives me 200. And 10,000 times 2 is equal to 20. 10,000 times 20,000, that's again a 200, right? So that is again basically so this matrix is the profit is 2% profit on gross sales in October. And these figures are in rupees, right? So this is for T1, this is for T2, and this is for T3, right? And this is F1, and this is F2. And that way you can calculate it. And meaning that you have actually calculated it. So 100, 200, 120, 400. This is supposed to be 400. Because 2 times 2,000 is 4,000. That's a 20,000. Actually, that I have made a mistake here. So this is then becomes a 400, 200, 200. And thus in October, basically farmer 1 receives 100 and 200 and 120 as profit in sales of each variety of rice, respectively. And farmer 2 receives profit of 400, 200, 200 in sales of each variety of rice, respectively. Okay. So that was all about properties of scalar multiplication of a matrix. And so the next thing that we have here to discuss is basically multiplication of matrices. I'll see you in the next video, and thank you.